All right, Algebra 3. Today we're going to talk about trigonometric identities, okay? These identities are kind of like writing a proof. And so part of what you have to do is you have to memorize a few of them in order to make this work, okay? So we have cosecant theta, sine theta, secant theta, cosine theta, cotangent theta, tangent theta. Okay? So here we go. Ready? A regular, like if it was cosecant, another way to write that is 1 over sine theta. Sine, 1 over cosecant theta. Cosine, 1 over secant theta. 1 over cosine theta. Cotangent, 1 over tangent. And 1 over cotangent. Now, so those are the reciprocal. They just kind of make sure that they're reciprocal of each other, all right? Any questions on that? Because at the end of the day, you have to understand that, because if you understand that concept, the rest of this will make sense. So, there's what's called the quotient reciprocals. Quotient reciprocals are only good for these two. And what would they be? Now, remember, tangent is sine theta over cosine theta. You should have written that on your paper. So what would cosine theta, cotangent theta be? That is correct. Cosine over sine. So what you have to do is you have to have these 8 memorized. You have those 8 memorized, that's going to help you quite a bit, okay? Quite a bit. So these are the first steps in your identity functions, okay? Okay, so if you're going to solve for identity, be able to put things into place in the practice, you're going to need these, okay? So now, next, there's going to be 3 functions that are developed from the Pythagorean theorem. Now, what do you mean, developed from the Pythagorean theorem? Let me explain. So if I have my drawing, let's think this through for a second. Theta, what would this be? X, or so this is X, Y, R, remember? So basically, you can develop a few of these theorems. In other words, remember if this is a unit circle, it's a unit circle, this R is always 1, right? So, remember your X value is always your cosine. So if it's X squared plus Y squared equals R squared, this is 1. So this would be cosine squared X plus sine squared X equals 1. Okay, so here's your first one. Okay, or they have theta, just depends on what you want, so theta. So that's your first one. Come in handy quite often. What's another one? 1 plus tangent squared theta equals secant squared theta. Okay? And then the third one is cotangent squared theta plus 1 equals cosecant squared theta. So these are your 3 Pythagorean theorem developed identities. Now, can I tell you that this is the one that you're going to use the most, because why? It's obviously the most basic scenario, okay? All right? Any questions on that? Does that make sense to everybody? So, what happens is you will be working through this concept. If there's a negative theta, if there's a negative in your little parentheses, so sign negative, you can move that sign out, that sign out in front of the sign. So, for instance, sine negative theta. Another way to work that is negative sine theta, okay? It's another way to rewrite that. Okay? Now, what happens if it's cosine negative theta? Think this through for a second. If it's cosine negative theta, what's going to happen? It's just going to come out and be just cosine. Why? Well, because it's on the x value, okay? And so therefore it's always going to be here. Okay? All right? It's always going to be on that side. Now, the other thing that comes in handy is sine and cosine. Cosine is always going to be, so that means if you have secant negative theta, what are you going to get? Secant theta. Okay? All right? Just remember that that will come in handy occasionally here and there. Now, the last thing you need to know is it's called cofunction identity. Cofunction identity. So in other words, all right, so all this stuff is stuff that you have to have memorized, okay? So let's think this through. One more set of things that you're going to need to remember. For instance, so sine theta. What would that be equivalent to when it comes to cosine? What would that be? Well, here's what it would be. It would be the shift, remember our shifts, right? Minus theta. So if I have sine theta, another way to write that is cosine pi over 2 minus theta. Okay, because it's subtracting it from this. Does that make sense? So here you go. Sine here, subtract pi over 2, it gets me back to my theta. Does that make sense? So just remember that. So if I subtract pi over 2 from pi over 2, it's going to give me back to 0. That's what this is. So let's think about it. What would be another cofunction?